Okay, so first thing we want to do is go ahead and complete out the hardware. So as a general design process, hardware is the last thing that I do. There's a couple of different ways to approach it. This is simple enough that, oh, and it threw up a warning over here, so everything can rebuild. All right, so I've got my shape. This is a little bit large, but it doesn't hurt my feelings. When I go to make this, I may shave that down to 1/8 of an inch. Depends on how much it flexes. So we want to start doing the stack ups, but I do want to go ahead and include the rest of the hardware. So only in assemblies will you get the toolbox. If you activate the toolbox and drag the toolbox components into a part, it will ask you, do you want to make a drive part? And you go, well, what's a drive part? And no, you don't want to make drive parts. Let me put it that way. All right, so under our options, the little gear up here, I'm going to do the pull down and go to add-ins. And then, of course, it put it on my other screen for me. And we have the toolbox library, which is what I want, which is going to be nuts, bolts, screws, pins, a little bit of everything. We'll take a look at it when we get into it. The toolbox utilities then are kind of handy calculators, let's put it that way. So the one I use the most in the toolbox utilities are the internal and external retaining clips. So when it makes that groove, and then also the O-ring grooves, it also has good starter dimensions for that geometry. And then I'll put up the website that I go to for the O-rings, because they kind of break it down even further. Is this a pressure seal? Is it a vacuum seal? And which way you load the O-ring into the tolerance zone determines, is it pushing into the gland or is it pushing away from, and is it increasing and sealing the pressure, or a whole nother conversation, that big thick 190-page book on O-rings and seals and gaskets that you never wanted to know that much. That's the fun one. All right, so also beam calculators. This will make various beams. We probably won't do weldments in here, but the weldments in SolidWorks, or the weldments that I've done previously, will pull up standard beam shapes. But if you've downloaded the ANSI set of profiles, you'll get most of those anyway. And then the cam and bearing calculator, life expectancy calculator, are pretty cool. All right, so we don't need that one. The other one that we're going to come back to as part of our curriculum is the tolerance analysis. Once we do the stack up with Dimxpert with model-based definitions, then we carry it over and start to do the tolerance analysis. So building those stack ups and the maximum conditions, I was trying to say, our worst case scenarios. Tolerance analysis will do that and generate the report. But a lot of times, depending on the complexity of the part, it's easier just to run through the math real quick and than it is to take the time to set this up. So if you're doing a lot of what if scenarios as you change and grow and shrink and rerunning, then it has value. But if we're staying fairly simple, we probably won't need it as much. All right, so on the design library then, so we're on our task pane underneath the resources. The second one down is the design library. The design library can be components that you've downloaded. So this R6 bearing that we downloaded from McMaster, if I wanted to use that everywhere, that's now my favorite bearing. I could put it into the design library and create a folder for bearings, and then I would just keep dragging and dropping that bearing in, or the bearings that I commonly use, and be able to reuse, repurpose, and have a single location for those bearings. On the toolbox, because we're in the assembly, we are looking at ANSI inch, and they do have bearings. So let's see what roller. All right, so those are like the needle, and then the instrument. Well, I kind of like having it tied to a part number. So thrust bearings, yeah, I can go a little bit further into it, and then we get to the bolts and screws. I didn't don't really think I need washers at this point, so do we want to do hex head? Yeah, most automation, most manufacturing is going to be, we're just going to pick socket head cap screws. All right, easy to work with. Question becomes, do I want to go with the standard socket head or a button head? Socket head. All right, so when I drag one of those in place, it should recognize the size. All right, and it goes to the default 1024. I set it for a 1032. And then the length is going to show up. So we have a fastener type and 1032, and the length under the head is on. Yeah, I want to say it's on the socket head. When you're dealing with flat heads, it's the overall length of the screw. And then I think button heads are also under the length. So 0.75. All right, so we're at 0.72. We'll see how much sticks out. All right, and then I missed something because it did not make the jump. So, well, we'll see what it does. Nope, I missed. All right, so the next one, I'm going to get a little closer to that cylinder, and that is that mate reference again, that I can just drag and drop those in, scroll over to the next one, scroll over to the next one, and I've got it. And then I'm going to X out of it. Right, and so what I'm doing by that mate reference is taking the place of adding a concentric and then rotating over and adding a coincident. And there's a little bit sticking out, but I'm not too upset about that, so I'll probably just leave it. All right, so 3/4 inch. Yeah, I can live with that. All right, so one thing of note, we didn't really look at it in the drawing, but let's check real quick, since I happen to think of it, is on sheet 5, that little spacer, then these should have gone up to 201 as well, because we changed that dimension, and that dimension was driving downstream data. All right, so if I wanted, I could go back and break that relation and say, no, this needs to be closer to the 190. I don't want it moving around that much. But in reality, the only critical dimensions are what we set, having the flatness, having the parallelism, or if we went back to the axis and the virtual condition, and since I'm here, I'll go ahead and set my center line. Having the axis and the virtual condition, I don't want to make it that complicated that it has to be perpendicular. From an inspection side, we'll stay with the flatness, and I'm not too worried about the 201. So just a quick check before we let that one go. And it threw the screen over on the other window again, so we'll let it save and let it update. All right, so I'm going to switch back to the pulley. So if it looks like I'm jumping around a lot and kind of all over the place, I am. It's just part of the process is that you have to address these things as you're thinking of them. If you wait 30 seconds, poof, it's gone. All right, if I think of it, I'm going to look at it right then, and when I accept or reject it, it's done. All right, so the 1/4-20. When I drag, yeah, I'm going to stay with the socket head. I want to see what it looks like as far as size. Well, it's pretty much, well, let me see if, there it goes. All right, so it found the 1/4-20. I really haven't done anything with it. All right, so if I go ahead and accept it, then, oh, and I missed. It's really not going through all the way through the first plate. So I'll do a Control-3, and we'll switch over to the hidden lines visible, and it only goes to the first plate. So, oh well, it's in the sheet. So what I'm thinking, no, confusing myself again. We'll go back to the solid. Is that head is 375, or through hole is 375. I haven't created any situation where this can have compression and actually hold on to the part. So that being the case, I do want to change its size from the 1/4 inch. Let's see what else we have available. All right, so I pulled up the 1032. No, now, since it is that size, I could standardize, right? So instead of 4, I'd have 5 1032s. The question is, am I going to be able to put a washer in there that's going to be able to cover that flange? So let's hide that one real quick, and we'll scroll back to washers, and we'll see what a plain. Yeah, we'll go with the preferred narrow. All right, so it found the 3/8, but that wasn't what I wanted. So 1/4 of an inch. All right, it spans and it goes a little bit larger, and then a 1032 or number 10. I'm going to go ahead and accept the number 10. And no, I don't need 2 of those. And it's basically a 1/2 inch. So that being the case, well, we have another minor design change. So when I open this and you say, I'd rather just order, a box of 1032s and be done with it. And because the length isn't that critical, well, they were 750. So I kind of got a little ahead of myself there. But if they're all 1032s, then I'm standardizing on the tooling and the tap. All right, so 1032, and then rebuild, save. I can close that one back out. All right, and then the 1032. Let's see what a 3/4 inch looks like. But there again, the assembly, that just goes horrific. So if I drag and drop one of the existing, well, it didn't quite give me the mate reference like the other one would, but it creates another instance of it, so I'm still kind of okay with that. And we'll go concentric, and then between the 2 faces can go coincident. And we have our hardware. All right, so looking at this now, when we go to the hidden lines visible, I'm almost all the way through the part. And I really don't need the 1032, that particular 1032, to be that long. So let's see, we had socket head, and I had, how did that get to be 6 unless I made one too many? Three, 4, 5, and then where is number 6 at? All right. So I'm going to suppress that one out as a maybe what if. The flathead washer is still in there. And then the number 6 was our 1032. I want to edit the toolbox component, so that lets me back in to the database and says, let's pick a different size. I want a length that is 1/4 of an inch. All right, so the washer is probably 049, so 200 thousandths engagement. I'm not expecting a lot of side load. All right, easy to assemble. I'm liking it well enough. All right, the other thing was that when we put the carabiner or the loop through there, it kind of has to clear, but I'm thinking that's a pretty good loop. So less worried about that. I'll take my chances. If I have to, I'll switch it over to a button head. Only problem with the button head is it going to be big, too big, and escape the envelope? All right, but I think we're okay on our geometry other than that. All right, so what that does when we save back the assembly, we go back into the fully sheet, the drawing, and switch to sheet 1. Well, I have a few more items. So since the bill of materials grew, and we haven't fully explored our stack up here, then now we have the items for the fasteners, and the issue is always I can't just send this out in an order because nobody knows what a hex socket head cap screw 0.19 10 by 32 0.75 0.75 normal is. All right, so basically the number 10, that is the major diameter, that is the threads per inch, that's the length. And then if there was a shoulder, that would be the length of the shoulder, and then that would be the length of the threads. So if I had a 2-inch long with a 1/2 inch of thread, this would be 2.00 by 1/2 inch, or vice versa, depending on which way it goes. All right, so number 10 washer, flat washer. So the couple times that I have produced this bill of materials and I've sent it over to I had it right, Copper State, and they look at it and go, what is this mess? How are we going to need the secret decoder ring to decipher this? And I say, it's not that complicated, it's just SolidWorks. And they go, yeah, write it out. Tell me what it is you want, give us our part numbers, and then we'll be happy. So a lot of times, if I need to, in the past, if we use something common, then I will go into the database, which is buried, strangely enough, under the SolidWorks and the SolidWorks tools. And let's see if I can find it pretty quick. Not copy settings, that's another one. Routing, no. Okay, where are you hiding? Oh, I'm not seeing the database. Oh, right there. Toolbox settings. Always at the bottom, last place to look. All right, you come into this database. This is everything. So when we needed a tapped hole for, let's see, what was the size of that thing? Straight tapped holes. No, tapped hole. And let's see, check the standards. Well, that should let me in. There we go. Is that we have thread data for much more. All right, so when I needed a a 3 1/8 or a 3 1/4 with some special thread, came in, found it, added it. It goes into the to the list. We can modify that database, and then let's see, name to match. One of them, since this table refers over to the thread data table, and if we come over here far enough, I don't remember where I put that. Size, thread diameter, I thought there was a note. And tap drill. I was thinking one of those I tied a part number to it. Anyway, probably in the thread description, was able to pull those out. All right. So point is there is way more than you want to get into, but if you have that custom size, this is the place to build it. All right, and then it's available in this system, because if you are not sharing across the network where everybody gets to it, you've basically modified your local database, and then nobody else sees that geometry. So it makes it even more fun. All right. So we update our list, and we have all of our drawings that we created. We have our A, B, CDE. And I did that, and I just realized that I probably shouldn't pull those as CDE. They need to be unique. So I was too busy running my mouth and not paying attention to what I was doing. All right, so in effect, come through, make this next pass, I find a mistake, I gotta fix it. All right, so F, G, and H. All right, so in the modification of the callout, we'll find a little bit more room. Going to double click, getting back in here. F, G, and H. All right, so if they're truly going to be unique from page to page, then we have to carry it through. All right, so it's an easy fix, but it's something that you get so focused, you may not catch it, may not recognize it until after the next pass. Or it goes to your checker and they send it back to you and say, no, you can't do that, and then you fix it and you send it back to them and they approve it. All right. So it pays to kind of just keep making those those references. Oh, and the parallelism is going to be for location. So since I'm missing a datum feature there, oh, didn't want to pull it off of that one. We'll pull it off of the flatness. All right, let me have it on the face. I'm going to stay consistent with my dimension. And then when we come over, I need a primary to J. All right, so pretty easy to get halfway through the alphabet without even trying. All right, but this becomes our document package, our piece. So our working document. Okay, we'll save that one more time. We'll go back into the assembly, and then we have on let's see, I'm not sure which level, but like on my commercial version, since I don't have the model-based definition, I still have Dimxpert. So you'll see Dimxpert and model-based definition are very close and use the same terminology. All right, so let's pick the pulley, and I'm going to open it up individually. And one of the things that we would want to build into our template, because I don't think it's going to do it on every sheet, so we may be I'll have to decide on that one. We're going to have to see what it does. So under the options, and let me pull over the options. We have under the document properties those Dimxpert. So if they're going to call it model-based definition, oh, there's Dimxpert there. Okay, hopefully they carry over then. We're going to look at these tolerances and see what it looks like in the build. So Dimxpert, overall drafting standard is ANSI. Right now we're telling it to do general tolerances, or block tolerance, general tolerance, or general block. And off the top of my head, I don't remember what those were. So if we go to block tolerance, this should open up. And then the tolerance class, medium, fine, coarse, very coarse, or custom. And then, okay, so here they are. General block tolerance length is plus or minus 20 thousandths. That's a little bit open. And the angle tolerance, half a degree. So I don't see where we can edit those, so we're just going to go into the size dimension. And right now our size diameters are plus or minus 5, length plus or minus 5. So apparently when I created this drawing template or part template, I went through and I modified. And location is plus or minus 5 because I think they stay plus or minus 20 or 0.5 for metric, half a millimeter. And then chain dimensions, geometric tolerance. So if you see something different, since this is kind of that introductory thing again, we'll decide what it's going to do and how much we need to control it as we go along. All right, and then the display options, where to place. So the one that I usually check for is on the slot dimensions. Do we want to do oversize with basic dimensions, or the if we do GD&T, basic dimensions, and where do we want to place those? All right, so the fourth tab over, Dimxpert Manager. This is where we're going to accumulate those tolerances. I still have that hesitancy to trust implicitly any auto scheme. So auto dimension, when we set for auto dimension, is this prismatic or turned? Well, it could be turned, but we're going to treat it as prismatic, see what we get, and then we'll come back and update, modify. All right, so for our reference dimensions, we gave it a primary datum of the face. And so basically we're creating a plane, or we need to create a width feature. Well, our primary datum is only going to be that face. And then what's the last one? A compound plane. All right, so The secondary datum should then be the opposite side, and it will also be the plane. And the tertiary datum, our third point, is we said we were going to do the outside. So I'm going to zoom way up to where I can get that cylinder. And we didn't continue the discussion, now that I think about it, that those were ×2. So hopefully I got that into my dimension. If not, that would be something to check for. All right, so all features, which can get pretty complicated. And then the feature filters, plane, surface, cones. If we don't have those, it really doesn't need to look for it. Bosses, fillets, chamfers, simple holes, counterboards, slots, notch, pocket. And then we will hit the OK and see what we get. Oh, secondary is parallel with the primary datum feature. Oh, that's right. I pulled that out as flatness, and then that one was noted. Oops. Okay, got out of it too soon. Let's see if it'll let me back in. So primary datum, and then really it was the secondary datum would be the cylinder. I was thinking that flatness, parallelism, but parallelism is in relation to. All right. Plane 4 is parallel. No, that's not what oh. Let me have the cylinder. All right, simple hole. Simple hole or the cylinder. Okay, third time's the charm. All right. So interesting that it pulled the 120 instead of an included angle. It treated it as an included angle over the outside. So don't know if it tried to pick that up as a countersink, but interesting. So since we left this as a plus or minus tolerance, 4-inch plus or minus 5, 874 plus or minus 5, if I want to change that, then that would be where we would go back and pick up the tolerance and change it from symmetric to bilateral or to whatever we needed. All right, so we're going to try to do a Control-Z. Well, since I don't get a Control-Z, we're going to come over to the Dimxpert history tree, and I'm going to delete all of those items. It's going to warn me to confirm the delete. There shouldn't be any absorbed features that I can think of, so yes to all, and that clears it back out. All right, so the auto dimension scheme one more time. If we go to geometric and the pattern dimensioning, linear or polar, polar would be centralized or pulling dimensions around the axis or circular fashion. So I can't think of anything that would be polar. So if you're familiar with AutoCAD, the polar coordinates, the at, and then the greater than symbols, I think. Been a little while since I've done that one. We'll go with the primary datum, pick up our secondary datum, see if I can select it this time. We get the cylinder, all features, and see what it gets. So what we're not doing is the selected features. I could go through and pick just the items that I want to be part of this dimensioning scheme and go with that. All right, so model-based definition, that's much more readable. Well, at least partially. All right, so the problem still comes down to what do I do with the angle? That wasn't quite what I was looking for. And we got the perpendicularity. We got a B datum. We got AB. We got a maximum material condition. So it went so far as to do in relation to A and B, but just B at the maximum material condition. And so can't really tell. So the diameter of 20 thousandths, yeah, it's kind of going into the V groove. And 2 times. All right, so 2 times would have to be for the 2 angles, but that didn't give me a basic dimension. All right, so 210 plus or minus 5 thousandths, and then the 2 thousandths flatness for the A. I don't see anything on the back that gave me parallelism to the back to A. All right, so let's go through this one more time. I'm not sure if that's the one that I want to stay with. And we'll do yes to all. All right, so the next dimensioning scheme, let's see what it looks like as turned. Know that we want the GD&T on this, so the plus minus we can pretty much bypass. And the primary datum is still the flatness. The secondary datum is still the cylinder. Oh, and I kept picking the interior cylinder. I think we wanted to go to the outside anyway. So whichever, it'll pick one. There we go. All right, so the turned. Notice that it went to run out as opposed to the true position. So with the turn, it's looking at how this is going to rotate. All right, within we have the 4-inch. Let's kind of pull this out a little bit, and the 875. All right, so since we went from the outside, it kept my perpendicular. So I do want that to come out a little bit. So the 874 plus or minus 5. Well, we would still have to tighten that up. But then the run out is 1/1000 of an inch, and the run out over here is 1/1000 of an inch, which is how true these two cylinders, these three cylinders, are going to run together. All right, so I don't think I need to take it that far. That complicates my my inspection. Does a little bit more than what I needed it to do. So one more pass. I'm going to delete those out. Yes to all. And I think there was the one more would be, let's see what it does as polar. And we kind of just discounted the turned on this one, so we'll stay prismatic. And what are we doing? Minimum number of holes. Well, we don't have any holes or to pick up that spacing, so we're going to go back to linear. So that kind of kicks that out. All right, so we'll try this one more time. Primary datum. And then we'll do the secondary datum at the OD. Pick one of the ODs and accept. All right. So the 120 and the 120, I'm not thrilled with those, but they don't bother me enough at this point. So the true position, 20 thousandths, we can refine those. Also notice that these are starting to maximum material condition, and then specifically to datum B. And then the bottom of the V groove just to datum B. All right, and then perpendicularity back to A, and that becomes datum B. All right, so kind of complicated. And, at the end of the day, what do we do with them? Well, let's save it. And I need to get back over to my first. And they should all be there. All right, so under annotations, actually, where did they go? Oh, there we go. So I did a Control-7 and they came back. What I want to be able to do is right-click on annotations and then turn off the Show Dimxpert annotations, and then we can toggle those back off and on, so that they're not always there in our work area. All right, so let's save that. I want to do a real quick check in the assembly, and let's rebuild. And if I go up to the annotations, we're still showing Dimxpert annotations, but this being a separate document, I just wanted to check real quick that is it going to bring over all of those annotations from the part into the assembly. So since I'm not seeing those, I'm a little bit happier about that. All right, we'll close that one. We'll go to the plate, and we're basically going to do the same things. Is come over to the Dimxpert tab so that we can see our list. We can auto scheme. Let's take a look at MBD. So model-based definition has that same grouping as Dimxpert. Right, so let's see, pattern feature 1, 2, 3, 4, 5, 6. That one added a datum. Oh no, there's the datum. Pattern feature. Well, need them side by side. guess I haven't looked at them as close as I thought I did. Anyway, datum target, surface finishes, weld symbols, dimensions. And then in addition is the model-based definition is adding those translations. So being able to put it out to a PDF. If I go to the next, outputting it to e-drawings so that it goes to the standalone viewer. A step file, and I'm not sure PMI compare. I'll have to look into that one. I haven't encountered that one before. All right, so the automatic dimension, basic location, basic size, general profile. So one of these we will need to try without the automatic, probably like that last one, the spacer, where we can do something pretty straightforward and not make it too overly complicated. All right, so we picked our primary datum was the one face. And then the secondary datum, if we try to stay consistent with the drawing, see if we are getting the same type of information, we'll have the two outsides, and then we'll let it pick the features. All right, so other than our tolerances, the number of decimal places and plus or minus 10, we're not too far off of what we just generated. All right, so what I don't see are the basic dimensions for the location. We got the slot tolerance, which kind of a weird way to call it out, but that works. Perpendicularity of 8 thousandths. So when we mentioned the doubling or the tripling, we have 2 thousandths. The perpendicular goes up by a factor of 2 or 3. And then the tertiary goes up by another factor, just so that that shape can go into the mix. All right, so since we didn't get some sizes in there, we're going to need to pull those. So we'll do one more save. And we'll go back into the assembly. And I'm just going to kind of run through these so we can get something started with the tolerance analysis. Oh, that's going to probably have to be next time. So same thing, primary datum, secondary datum was the bottom, and the tertiary datum was the sides. And then linear and geometric. All right, so a few more. We've got the 1032 call out. Oh, okay, it was like, saw some extra boxes there. All right, so as far as its basic position and location dimensions, that looks like something we'll have to go back and add. But the standard tolerancing as far as size and the size, width, and thickness, those are all pretty standard. So we can go through and get this started pretty quick, but then just like we did with the drawing, if we're going to stay with this, we need to have it pretty consistent. All right, so we did the 2 plates, we've got the pulley, and then last will be the standoff. Oh, we need the axle in there. Well, we decided the axle will be our plus minus, so we'll stay with the plus minus on that one. All right, so let's go with a size dimension, and I'll pick the outside. All right, and that one was pretty open. So I'm hoping this one will be simple enough that I won't have to chase it too far. And then the through will be another size dimension. And then we'll see if we have a size dimension that will be between 2 planes. All right, so create a width. And then I pick the other face, and we accept. Then that's going to set the width dimension. All right, so this is the one that we set as the flatness and parallelism. And so it kind of pulled it off a little bit, but we can still see the geometry. All right, and then if I pull a datum, and it's just going to be on the face. And do we go with Well, let's see if we can attach it to the, so I think it works the other way. Should have applied the tolerance, and then we come back to the face. So flatness, well, we're off by a little bit, but there we go. Okay, so flatness of 20 thousandths, not quite, but it's a start. And then the geometric tolerance, we will be at, whoops, I clicked out early. So we want parallelism, and that is going to be in relation to datum A. So we can place it on that face, and I think it needs to go to the plane. Not sure why it's picking up the width feature, so I don't really think that's a width feature, but I'll have to check into that as to how we're calling that one out. All right, so the downside is it's a little messier, maybe. We're going to be able to rotate and see it in 3D, but we're still going to have to go in and adjust those tolerances. All right, and then the last one was the axle. So open that one. All right, and we'll do the automatic scheme as turned and plus minus. We set our primary datum. Well, we still have to pick a primary datum, so let's go with the cylinder, and then actually one of the end geometries would probably be good. So I'm not entirely sure what I'm going to get here, so we'll go with the cylinder, and those would make that parallel thing again. Let's go ahead and see what it gets. All right, so pretty much kind of the tolerances that we had, sizes that we had on the other, except for the 374 to 3745. All right. So we've been through, we've got a Dimxpert on, or a model-based definition on all of these. And then we can kind of start from there going into the tolerance analysis. All right, so we're going to call this one good and take questions.